All right, we're going to talk now about piecewise functions. And what it really means is that you have pieces. So let's look at what it looks like on a graph. Okay, you might have one piece where to the right of some number, for example, it acts like a line that's increasing at a certain rate. And you could say to the left of it, you're going to have it work like a flat line. Okay, and a little bit lower. That's an example of a piecewise function. Sometimes piecewise functions connect. Sometimes they don't. Sometimes they're just lines. Sometimes they're a combination of lines and parabolas and other curves and dots. Here's another piecewise function. These are the kind of piecewise functions we're dealing with a lot in calculus. You'll have something like an absolute value graph, but at the top, it's undefined. And what they do is, at that point, they'll define it way up here. There's another piecewise function. Every x-coordinate has exactly one y-coordinate. So those are some graph examples of piecewise functions. So what do they look like in writing? Well, they got these big brackets and stuff. And for example, here's a piecewise function. F of x equals two different functions. It equals 3x plus 5 at certain times, and it equals 4x minus 10 at other times. And over here is the when. This is the when. This is the how much, the y. So the when is going to be our domain. Let's say it's going to be this when x is less than 0, and it's going to be this when x is greater than or equal to 0. Okay, so what does that mean? Well, that means if I'm trying to find f of -3, I got to find out which category it goes into. Do you think it goes into the top category or the bottom category? Use your hand right now to point up to the top or point down. I want to see on your screen point up or point down. Which category does f of -3 go into? I want to see everyone give me an answer. I'm looking all over my screen right now. Some of you, I only see your foreheads, so it's hard to even see your hand. Okay, it is the top, because when x is less than 0, this function is going to apply. So I'm going to use this function for evaluating here. 3 times input plus 5. My input is -3. I'm going to get -9 plus 5, order of operations. My answer is going to be -4. Notice right now, I'm not even worried about the graph. I could graph it, but right now we're just evaluating values. Let's try another one. F of 0. This time, I want you to decide which category it is and then do it. And type your answer into the chat bar, the chat box. Tell me how much f of 0 is and type it into the chat box. We're seeing a lot of -10s and a lot of 5s. It's definitely one of those. Okay, I'm still staring at the chat. Lots of 5s, a couple of -10s. Okay, let's look right here. Let me ask you, so we're doing 0. Is 0 less than 0? No, it's not. Is 0 greater than or equal to 0? Yes. So we're going to use the bottom equation, the bottom expression. 4 times input minus 10. Plug in 0, and you get 0 minus 10, which is negative 10. Those of you who said negative 10, give yourselves a pat on the back. Yeah. Let's do another one. Let's make it funky. 2.1. Can you do it? 2.1. Decide which category it's going to go into, and then apply the function. Go ahead and type in your answer into the chat box. You can use your calculator, by the way. Ooh. Okay, it's looking like everyone's getting negative 1.6. Well, let me ask now, does it go to the top or the bottom? I think it's going to go to the bottom. Yeah, Emily. It's greater than 0, so I'm going to rewrite the same type of expression I did earlier. And we're going to put in the 2.1 here. And let's see what happens here. 4 times 2.1 is 8.4. And my answer is negative 1.6. All right. You guys were all right on that one. Let's do one more of these. And let's get a little more difficult. And I just dropped my mouse. I have an old-fashioned mouse here. This one's going to be harder, and none of your homework is going to be this hard. But I want to challenge you already. So I find that when you challenge students with the harder problems, then when they go home and do the homework, they go, "Oh man, this is no problem." So let's do f of x equals 2x squared and negative x. This will be when, ready? The absolute value of x is less than 2. And this is going to be when the absolute value of x is greater than or equal to 2. Now, it doesn't have to cover the whole number line, but I want you to know this covers the entire number line. Every single number works in this function. And it makes sense because this is the distance from 0, right? And your distance from 0 can either be less than 2 or greater than or equal to 2. Every single number has a distance from 0 that's either less than 2 or greater than or equal to 2. So let's try one now. F of negative 1. Decide which category it falls in, and then plug it in. Looks like we have to take its absolute value to see which category it falls in. Which one do you say it falls in? Point up for the top one, point down for the bottom one. Okay, I'm seeing most people say the top one. That's correct. If I take the absolute value of negative 1, it's going to be less than 2. We're going to use the top equation. And I'm going to write it with parentheses where I see x. Let me put my input in there. And type your answer into the chat bar. Good. We're getting a lot of 2s. Order of operations says we have to do the exponent first and then multiply it by the number in front. Okay. Let's do f of how about negative radical 3? F of negative radical 3. I'm going to give you about 30 seconds to try it out, and then I'll start asking questions about it. Ruth, is your camera working?
No, it's not. It's like getting blurry or something.
That's okay. A blurry Ruth is fine. It's just I don't want Mr. Miller to come in and say your students don't have their cameras on. Otherwise, he'll say to go to the school and go get another device. There we go. Okay. Caitlin, where is this number going to fall? The top or the bottom category here?
Negative radical 3 is going to go into the top category.
How did you decide that?
Well, the absolute value of negative radical 3 is just radical 3. And then I put in my calculator what radical 3 is, and it was 1.4 something. So
okay. That's excellent. Just so you know, radical 2 is 1.4 something. Radical 3 is actually 1.7 something. But your process was perfect. So as you all see, she changed it into a decimal using the calculator, and that's exactly what I wanted you to do. And I picked one that would go up here because we're going to square it. So it makes for a really nice problem. What do you get when you square negative radical 3, everyone? Jillian, tell me what you get.
3.
3. It becomes positive because you're squaring it, and then you have a 2 out here. And what's 2 times 3, everyone? That's right, 6. Check mark, happy face. How many people got 6? Give me a thumbs up. We got a thumb and 4 more fingers up. I like that. Okay. All right, so that's how you do those piecewise functions. What if we had to graph it? Do you think we could graph a piecewise function? Let's try it, and we're going to do a simple one. F of x equals 2 if x is greater than or equal to 3, and it's equal to negative 2 if x is less than 3. Here's how we graph it. I can see that the split here is at x equals 3. So I'm going to go over to 3, and I'm going to kind of think of it like 2 halves. Okay? I don't normally graph this line on my graph, but I'm doing it just to demonstrate. What I really do is this. I'll take a piece of paper. I'm grabbing paper right now. 1 second here. Oh, wait, I've got a different color paper. Let me use that one. Oh, where'd it go? I don't know where it went. Here we go, an envelope. So I'm going to put my envelope here at 3. Let me write the 3 so you can really see it. So I'm going to put my envelope here at 3. To the left of 3 is going to be one graph. And I look here, which one is to the left of 3? It's the one that's less than. To the left of 3, I'm going to graph the line y equals negative 2. That's just a horizontal line. Now, Since it's only less than, not less than or equal to, I'm going to put an open circle right there. 3 is not defined on that line. Now I'm going to go to the other side. And for the numbers greater than 3, I'm going to graph it at 2. Y equals 2. So I'm going to go up to 2, and I'm going to do a horizontal line that way. It has the equal sign on the greater than or equal to sign, so I'm going to put a dot. There's my answer. What do you think? Seems okay? Let's do a harder one now. Let's do one involving an actual slope and y-intercept. Okay. Let's say we have f of x equals 2x minus 1, negative x plus 4. And let's do it x greater than or equal to 1, x less than 1. There we go, sorry. Here we go. Okay, go ahead and copy that down, and then we're going to do it. Okay, so watch how I do it, because I do it a special way. So here's my 1. I know that's my cutoff point. Now, for each of these functions, I want to know what happens at 1. Let's start with the top one. If I plug in 1 to this function here, f of 1 is 2 times 1 minus 1, which equals 1. So I'm going to put a dot at the point 1, comma 1. And the reason I'm putting a dot is because I have the equals to right there. If I didn't have the equals underneath, I'd put an open circle. Now, we haven't talked about it, but why don't you tell me, what's the slope here? What is the slope?
2 over 1.
2 over 1. You can go up 2 over 1, up 2 over 1, and draw your line. You can also put in 2 and get another point. 2 times 2 minus 1 is 4 minus 1, or 3. So I can get another point. I can either apply the slope or get another point. And I got another point. There's that side of the line. Now, let's do the bottom part. If I plug in 1 right here, what will the expression equal? Well, you've got negative 1 plus 4, and negative 1 plus 4 is 3. So we're going to go up to 3 and put an open circle. Okay? I'm going to go ahead now and plug in another point. I'm going to plug in 0 because I need to know what's going to happen to the left. Plug in 0, and I get negative 0 plus 4. That means I need the point 0, comma 4. And here's the rest of my graph going up in this direction. We just graphed the piecewise function. Now, maybe it's going to be more useful if you do this. I just thought of this, so I've never done this. I know my breaking point is the 1, right? And I plugged in 2 because I need another point bigger than that. And those belong to the function y equals 2x minus 1. So when I plug in the 1, I get 2 times 1 minus 1, which is 1. That's the point 1, comma 1. When I get the 2, I plug it in here and get 2 times 2 minus 1, which is 3. That's the point 2, comma 3. Now we do the other side. And the other side, we just keep counting down. 2, 1. We need the 1 again, and then 0. Why do we need the 1 again? Because look, we have two values at 1. One of them has a closed dot, one of them has an open dot. So here, we're doing y equals negative x plus 4. So plug it in. Negative x plus 4 equals 3. This is the point 1 comma 3. But it has an open circle because 1 is not really in that part of the domain. Here I've got negative 0 plus 4, and that's 4. And 0 comma 4. And those are the 4 points I have graphed on here. And then I drew my lines. I'm going to give you a moment to copy this down. I think this is a good organizing method. Okay, I'm going to move the paper. Tell me to pause if you need me to wait. We're going to do one more. Okay, let's do f of x equals x squared for x is less than 1. And let's say it equals 2x plus 1 for x greater than or equal to 1. Let's start organizing it the same way we did earlier. My cutoff point is 1. So I'm going to do 2 1s. For the bottom half, we're going to do the equation y equals 2x plus 1, because that's the numbers that are greater than 1. For the top part, which is the less thans, we're going to do y equals x squared. Up here, you need to count down. And over here, you need to count up. Notice I'm putting an extra number in there this time because I have a different kind of equation here. I have y equals x squared. If it's just a line, a linear equation, you only need 2 points. Okay, let's start by plugging it in over here. I'm going to get negative 1 squared, which is 1. The point is going to be negative 1, 1. Here I've got 0. 0 squared, because my function is x squared, is 0. I've got the point 0, 0. 1 squared is 1. I've got 1, 1. Let's go down here with the other function. 2 times 1 plus 1 is 3. I've got the point 1, 3. 2 times 2 plus 3 is, 2 times 2 plus 1 is 5. I've got the point 2, 5. Look at our original equation. 2 times 3 plus 1 is 7. It's counting by 2's, huh? 3, comma, 7. Now let's graph it. I'm going to graph this part first, and I'm going to have an open circle at 1. So I've got 1, comma 1 with an open circle. I've got 0, 0 with a closed circle. I've got negative 1, 1 with the closed circle. And I can see here's my parabola on the left side of my breaking point. The left side of that. Over here now, I'm going to have 1, comma 3 with a closed circle. 2, comma 5. Oh, it's climbing. And I don't even want to do the next one. I know this is a line. I just do a line up to the side. This is our piecewise function graph. I'm going to go ahead and shut off the video. Give me 1 second here.